Welcome to Science Store online classes.
Don't forget to like our video and subscribe our YouTube channel for all the updates.
Welcome to all of you once again to the physics classes. Dear students, we were talking about gravitation, and in the case of gravitation we have studied that acceleration due to gravity on the surface of the earth, above the surface of the earth and below the surface of the earth we have studied. Now what actually next we are going to study? There is nothing but some of the important topics. So when we talk about, we have discussed about work, power, energy. We have studied about work done. Work done is nothing but what? That is nothing but force into displacement, no? And that work done we have talked about, we have called it as just potential energy. Okay. Now we have a concept called gravitational potential energy. We have a concept called gravitational potential energy. So gravitational potential energy, okay, so which is denoted as U, okay, capital U, like this. So what do you mean by gravitational potential energy? So gravitational potential energy means the potential energy because of the gravity. Where there is a force, there is a work done. There is a work done means that work done becomes as a gravitational potential energy. Now it is found that force F is equal to mg, whatever we have written, the gravitational force is actually, this is no, g into m1 into m divided by r square, and it is no longer same. It is no longer same or constant. It varies from point to point because of r. It depends on r, and that's why the potential energy or the work done is also going to change. Now suppose I will consider a height from the surface of the earth. This is h1. Next here this is h2. Now here work done is mg h1. Here work done is mg h2. The work done from the point 1 to 2 is, there is nothing but difference in that, right? There is nothing but difference in that. That is nothing but mg h2 minus mg h1, right? That is the work done, and that is what we are going to study. And that work done is nothing but gravitational potential energy. Gravitational potential energy. So what happens, since r is equal to goes increases, so as you go away from the earth, away and reach to the infinity, this gravitational potential is no longer sufficient to hold on you. You will be escaped from the gravitational pull of the earth. You will be escaped from the gravitational pull of the earth. Now because of that, we can say that gravitational potential energy at the end, at the point of infinity, is zero. Means there is no potential energy, there is no work done, right? So that's why we are going to define the gravitational potential energy means work done. Potential energy means work done. Since at infinite point potential energy because of the gravitational force is zero. Since because of the infinite distance gravitational potential energy is zero, now what we are going to say is, we are going to define a point mass. What do you mean by point mass? As there was point object, a smallest mass we are going to call it as point mass, that's all. A mass, a smallest mass. Now smallest mass is here, which is connected with this gravitation, means it is having some potential energy, because everywhere on the height it is having potential energy. But as you increase the distance, and it becomes very large, because the force is nothing but this much, no, 1 by r square, no. Now force is reduces, so work done or potential energy becomes reduces and becomes zero at the infinite distance, right? Now so that we are going to define the potential energy, or I can say gravitational potential energy is nothing but it is the work done. You can write down the gravitational potential energy is nothing but the work done to bring an object from infinity, okay, into a certain distance in under the gravitational field. What is that? Gravitational potential energy is nothing but it is the work done to bring a point mass from infinite distance into the gravitational field or the field of the planet or field of the earth. That is gravitational potential energy of the earth. Now, what is the expression for that? What is the expression for that? How I can write down gravitational potential energy? What actually it is? For that we have a derivation. We have a derivation. So the amount of work done in bringing the body from infinity to the given point within the gravitational field becomes gravitational potential energy. Now we will calculate it. We will calculate it. So earth is there whose mass is supposed to be, we will assume that the mass of the earth is concentrated at the center, because in centripetal in system of particles we have studied about all those things, right, extended objects and all. So we will generally consider at the center that point of mass of the earth is concentrated. Now when you talk about the gravitational potential energy, this is the point which is having mass m, which is at a distance, infinite distance. Say for example, this is infinite distance, okay, very large distance. How we have defined? We are defining that the potential energy, that is nothing but it is the work done bringing a point object from infinity to the point somewhere, okay. Now somewhere here I am going to move towards the gravitational field for a distance small x. Suppose this is at a distance x, means it is in the gravitational field x, okay. Now I am going to move it to a certain distance x, dx, okay. So that, see, it is like this, it is earth is there, this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, infinite. Now somewhere 20th position that m is there. Now I am going to move it to the small distance. Later I will bring it to the distance r, or 5 centimeter means like this it becomes. So generally I can write down in this way. Now what is the work done? What I have to do? Potential energy is nothing but work done into force into displacement. For small dx, small work done, first I will calculate for the small work done, later I will integrate it as we have done in the case of work power energy, and total integration, total potential energy we are going to find out, okay. Now this is what the work done when you bring this point mass to a distance dx into the gravitational field. What do you mean by gravitational field? Gravitational field is nothing but the range where you can experience the gravity. You go to the moon, you will experience the gravitational field of the earth, but if you go outside the galaxy, you are not going to experience any gravitational pull of the earth, because the range is less. Means range is, it is high range, but out of the gravitational solar, out of the galaxy, you are not going to experience the gravitational pull of the earth. Certain range is there, but you may experience the gravitational pull of the sun in the solar system, okay. Now what we are going to study, that is nothing but this is the thing. Now at a certain distance x, what is force? Force is equal to G into m divided by x square. So while writing the derivation, what you have to do? Consider a point mass at a distance x from the center of the earth, okay, and capital R with the radius of the earth, and capital M is the mass of the earth, okay, like that, and mass m is the small m is the mass of the point object. the force, let dW be the work done to move the object to a small distance dx from infinity to a distance dx. Okay, that is small work done, small work is done, that is that much. Now the force experienced at a point at a distance x by that object is F is equal to G m into m divided by x square. So work done will be equal to how much? G into m into small m x square divided by dx. But that is work done for a small distance dx, right? That is the work done for the small distance dx. Now I am going to bring that object infinity not to dx but more than that, nearly equal to the earth. Say I am going to move from infinity to the distance r. See, work is done means the earth is there, object is there, it is pulling that, but I am slowly bringing, means I have done the work against, right? Already falling it, but slowly I am bringing, no, like that. That is the work I have done, no. So that work done will be integration of dw, which is equal to w, which is equal to integration of, from where did you bring? From infinity to the distance small r you have brought, and dw is nothing but that is g into m divided by x square into dx. Now g, m and m is constant, I can write down it outside, m into m divided by, it will be an infinity to r into 1 by x square take it to the numerator minus 2 dx. What is the integration of x to the power n? X to the power integration is x to the power n plus 1 divided by n plus 1. So if you integrate it, x to the power n plus 1 divided by n plus 1, from where to where? From infinity to r. Now n means here minus 2, plus 1 is plus 1, so you are going to get g into m, what happens? Minus you are going to get divided by 1, x to the power minus 1 you are going to get, I will write down divided by x. This is w. So I will write here, you must know to apply upper limit, we will call it is lower limit, upper limit first and lower limit later you have to apply. So work done which is equal to minus g into m into 1 by r, upper limit 1 minus 1 by infinity, lower limit. Infinity means what? 1 by 0, no? 1 by 0 is infinity. So this becomes 0. So this term becomes 0. So w is equal to minus g into m divided by r. That is nothing but the potential energy. But we are not supposed to write down the potential energy w as w. We are going to write down it as u. Okay, u of r, the potential energy is the function of r. Potential energy is the function of r, which is equal to g into m divided by r, and this is nothing but the potential energy. So what did we write? This is for 3 marks or 5 marks they are going to ask. A very important derivation for you in the gravitation chapter, as well as which is very important for your competitive exams, their formula and how you have taken these values and all, because same type of the questions you are going to get here, okay, that is the thing. Now u of r is nothing but it is inversely proportional, right? See, force was inversely proportional to square of the distance, but potential energy is inversely proportional to this. And this force is conservative force, right? This force is conservative force, so the work done is depends on, gravitational force is a conservative force, and work done is depends on initial and final points, not on the path. That's why initial and final points are important for us. So infinity to that point, in that way. Okay, this is what potential energy is, gravitational potential energy. So what we are going to do, just learn the derivation, which is very important. So what do you mean by gravitational potential energy actually? Gravitational potential energy is nothing but which is the work done to bring point mass from infinity to the point into the gravitational field. Now this is gravitational potential energy. We have a new term that is called gravitational potential. Gravitational potential. What do you mean by gravitational potential? Gravitational potential means it is, see, potential energy is nothing but the work done to bring a point mass from infinity to that point, whereas gravitational potential is nothing but it is the work done to bring a unit mass. Unit mass means 1 kg. See, for any mass m, the gravitational potential energy is G into m divided by r. And if it is 1 kg, how much? Cross multiplication. So gravitational potential is nothing but, we are going to define it as V, which is nothing but potential energy divided by m. Potential energy, see, I can write down it is, so that G into m divided by r into divided by m, right? So divided by that, so I can write down that it is G into m divided by m into r. So potential is nothing but which is equal to G into m divided by r, which is nothing but gravitational potential for unit mass. Gravitational potential is nothing but for unit mass. So what is that? It is the potential energy to bring the object from infinity to that distance, to the distance m. In that way it is. Okay, so this is what the gravitational potential is. Very, very important. Don't confuse with gravitational potential energy and gravitational potential. Very, very, very important for the competitive exams. Potential is for unit mass, potential energy for some mass. As I did the cross multiplication, in that way it goes. Okay, so that is very important. Hence we will conclude here for the gravitational potential energy. Okay, so this is what the derivation. Now why this gravitational potential energy is negative? Why this gravitational potential energy is negative? Whenever the energy becomes, see, there are three scenarios. One is negative, one is positive, another one is zero. You have positive energy, you have negative energy, and you have no energy. Okay, positive means what? Positive means use itself having some energy, so need not to give any energy so that you can escape from one point to another point. But here any of the object is bound to the system, right? See, earth is there, any of the object is bound means whatever the object you are going to throw it, what happens? It comes back again. No, means that point object is bound to the earth, it can't go anywhere. No, that's why its energy is negative. And wherever, see, it goes outside. See, now we will send satellites or any spaceship, what happens? It will go outside the space. No, so why it goes? Because large energy are given, large energy are given. What happens? It goes and at the end, at some point, what happens? It escapes completely from the gravitational pull of the earth. It escapes completely from the gravitational pull of the earth. Means it is free. Means it is free. It is having some positive energy. Now the negative energy means it is bound. Positive energy means it is free. Okay. And zero energy means it is having no energy. Like that it is. Neutral. Okay. Forget about that positive energy because we can't say here, and as you have studied for electron is bound like that only. So here for the gravitational force, that point is bound to that gravitational. It cannot escape from the gravitation. It has to escape from the gravitation means, or it has to become free means, zero means free energy. Okay, zero energy means free. It has to become zero means plus G into m divided by r you have to do, no? Then you are going to get it as zero, no? Plus G into m divided by r, no? You have to get it as zero, no? Right? Yes, to make it as free. Okay, and that is the thing. So negative means the system is bound to the gravitational pull of the earth. That's why, so gravity is so strong, okay, whoever may go up, it will pulls down. No, it pulls down. That's why from the gravity we can learn a life lesson also, right? Yes. And this is what the gravitational potential energy is and the gravitational potential is. Here I am going to conclude about this gravitational potential energy. We were talking about gravitational potential energy, and object is maybe having it is positive energy, negative energy or zero energy. Positive energy means what? It is having its own positive energy, it can go anywhere. Negative energy means it is bound, and zero means it is free. That's all. It is not having its own energy, but it is free. And now we were talking about object is there. If I am going to throw it on the gravitational field, it comes back once again to the earth. Why? Because gravitational pull is there. Now my question is there, I have to throw the object in such a way that the object should not, it never and ever should not come back to the earth. What I have to do? I have to give a speed, I have to give a velocity, I have to do the work. I have to give a work, I have to give the velocity means, and that will be going to escape from the gravitational pull of the earth, and that is nothing but escape speed, what we are going to study in today's class. What do you mean by escape speed? Escape speed is nothing but the minimum energy required or minimum velocity required for an object to escape from the gravitational pull of the earth. Right? Minimum velocity is required to minimum speed, we will say. Okay. Now what I have to do? Having earth is there, one object is there, from the surface I have to throw it and it should not come back, means it is reaching to the infinity, right? It is reaching to the infinity. What I can do? I have to work. I have to work in such a way that it will go somewhere. The work I have to do. What is that work? Work is nothing but simple. Say for example, I am moving it to the dx distance. No. Moving it to the dx distance. That dw is nothing but f into dx. Right? What do you mean by f? F, say somewhere x is there. G into m divided by x square dx. This is dw. Right? That dw which is equal to g into m divided by x square dx. This is the small work done. Now what is next? Next is, there is nothing but equal to the kinetic energy. What I have done? What do you mean by kinetic energy actually? Kinetic energy is nothing but how to measure it. A car is moving with the velocity, mean how to find out the kinetic energy? By stopping it. What work I have done to stop it? That work is equal to the kinetic energy the car is having. Okay. So here also what velocity I have given, that work is equal to the kinetic energy. Now kinetic energy I can write down, which is equal to half mv square. That this work done, but this is not the work done. It has to escape, means what I have to do? The work I have to do integrate. No. That is nothing but w, which is integration of dw, which is you are going to get integration of this g into m divided by x square dx from 0 to, from r to infinity you have to integrate. You are sending that object not from r to x, you are sending that from object from r to infinity. Then only it will escape from the gravitational pull of the earth. Otherwise it is not going to escape from the gravitational pull of the earth. Now this if you do means g into m into x to the power minus 2 integration of r to infinity. So you can write down g into m okay, x to the power minus 2 plus 1 divided by minus 2 plus 1 divided by 1 by x you are going to get. It is from r to infinity. So which is equal to g into m. This is 1 by infinity upper limit 1 by r. Okay. So g into m 1 by infinity means 0 minus r you are going to get. Okay, already one minus is there here, that we are going to get here. So minus of minus plus we are going to get. So I am going to get that work done, which is equal to G into m divided by capital R. Same as that of the earlier derivation, no? Now that work done is equal to the kinetic energy, right? I'll erase this so that I can write down here. That work done is equal to kinetic energy, which will it attain. So mv square by 2. V square when escape square I am going to put, which is equal to G into m divided by R. G into m divided by R. So cancels, V square, which is equal to 2 into G into m by R. No? But we know that G is equal to Gm by R square and Gm is equal to Gr square. So Gm I can write down V square, which is equal to 2Gr square divided by R cancels, V square, which is equal to 2Gr. And I can write down V is equal to square root of 2Gr, which is nothing but escape speed. Means this much of velocity if you give the object, never it is going to come back to the earth's surface. We will send the spaceships, we will send any of the object, not satellites will be not gone out, but you have to give escape speed, that is nothing but 11.2 kilometer per second, more than this. So if you calculate this, you are going to get 11.2 kilometer per second. That is nothing but 11.2 kilometer per second it has to move in that speed. 11.2 kilometer per hour. Okay, so that is the escape speed of the earth. That is the escape speed of the earth. Or else 11.2 kilometer per second, that is the escape speed of the earth. 11.2 kilometer per second, there is the escape speed of the earth, and for a moon it is different, or different objects it is different. For earth it is 11.2 kilometer per second. For 1 second 11.2 kilometer it has to travel, no, that much of velocity you have to give, and it is never going to come back to the earth, and that is what escape speed is, So this is about the the thing which we are going to study. Okay, and so here I am going to conclude by saying this: read all the topics for your competitive exam, read the things. Okay, so thank you very much.
Don't forget to like our video and subscribe our YouTube channel for all the updates.